Okay, welcome on board. I can see you, Elvis Kilichi, Sunday Princess, wow, Solomon Jude, Umwabo Infanyi, FUT Mina, SVG, right? Elvis Kilichi, okay, um, Fad Abdurazak, and a whole lot of you out there. So, I will not bore you with this. Let's move on to what we have for the day. Well, we're going to be dealing with integration shortcuts. Now, yeah, it was yesterday I was taking tutorials for some people and then they entered one question integration by parts. Hey! After integrating first round, we still had to integrate by part next round and it was so long. So I said, no, let's try this shortcut and it worked. So that's what I'll be teaching you today. Let's stay tuned, but we'll be starting from the little integration we have. Integration, you have the integral of root t dt. Now, how do we solve this? You know, if you have square root of something, is rewritten as t raised power what? 1 over 2. So what you just need to do, add 1 to this. You have t, add 1 to this, it gives you 3 over 2, right? Over what? 3 over 2. So plus c, this becomes your answer. But if you want to get your answer, the type of answer you'll be seeing in your option, what you just need to do is, okay, let me leave this side. What you need to do is write t 3 over 2, right? And then you have 2 over 3. You interchange it. This is the way you see your answer in e-exams. So it's as easy as possible. I think I have a question like that. Let me look out for one. So we just solve. Okay, I'm not able to find one for now. Yep. So let's just move on. If I see it later, we'll solve it. So now we have this question. Integral of 2x plus 3 over x squared plus 3x plus 5 dx. So I told you integrate. Now before we move into this, if you are here to share to your friends, ensure you do well to share to them. The goal is that this video, this live session helps you in your exams. So please, if you have any questions, do well to put it in the comment section. We'll get back to you. And as much as possible, I'll try as much as possible to break it down little by little so that you will understand and you have better results this semester. So now if you have something like this, the shortcut, what we need to look out for is, if we differentiate this, are we going to get something that looks like the numerator? If it's yes, it means our answer becomes what? Lean everything we have here. X squared plus 3x plus 5. So this becomes our answer plus c. This becomes our answer, lane of this. So you know, if you differentiate this, you'll be having what? 2x plus 3, which is the same thing as this, right? So if it's the same, you are sure that they are going to cancel out. Once you just differentiate what is at the denominator and it gives you this, it means that your answer, you put in brackets what is at the denominator. So I'm sure this will save you a whole lot of stress in your exam. So let's move to another one. We have integral of exponential 5x plus 2 dx. Now we have been solving a whole lot of questions. How it's going to profit you is if you're able to understand it and then solve more questions. Like now, we've done something involving square root, we've done another thing involving something over something. So make sure you understand it and look for past questions. Solve more questions so that when you see that particular type of approach in your e-exams, you'll be able to solve it flawlessly. So now we have this. Now, if I told you to integrate this, it's very simple. Put this same thing here, exponential 5x plus 2. The only difference is, differentiate this, you have what? 5. 5x plus 2, it gives you 5 now. put it underneath. So you have what? Exponential 5x plus 2 over 5 plus c. It's as simple as that. You do not need to stress your brain and the rest. Then before I go further, one way of finding your the another shortcut that works most of the time is when you are told to integrate. If you are very conversant with differentiation, you start to differentiate the options. We'll solve something like that. You start to differentiate the options, and when you differentiate option A, it does not give you what is the question. It means that option is wrong. If you differentiate option B, it matches with the particular question, it means you are very, very correct. So just watch out for that. Okay, so let's solve another question. Okay, sorry for that. So we have another question. Okay, let's clean this. The integral of cube root of x. The integral of cube root of x. So while solving this, you know your answer is what? You know it's also written as x raised power what? 1 over 3. Yes. You know it's also written as 1 over 3. So what you do, add 1 to this. Your answer will be what? X raised power what? 1 over 3 plus 1. 1 over 3 plus 1, you will be having what? 4 over 3. Over what? You have 4 over 3, it becomes 3 over 4 plus c. And that becomes the answer. You get. So let's solve more. Let's solve more questions. We're just dealing with shortcuts. Okay, so you have this question. The integral of, in bracket, 3t plus 2 raised to power 4 dt means we are told to integrate with respect to t. Now what we're going to do here is we take this, assume this to be any variable u. When we integrate it, we will be having 3t plus 2. Now, as an integral, it's adding 1, right? 5 over this same 1 that is here. But you're not stopping there. Times, differentiate this. Differentiate 3t plus 3, you have what? 3. So your final answer will be what? 3t plus 2 over 15 plus c. Now I'm going to go over this again. You know normal. If you have x raised to the power of what? 4, and you're asked to integrate, you will do what? X, add 1 to 4, it gives you what? 5. And this 5 here, you bring it down over 5. So it'll be x raised to the power of 5 over 5. So it's the same scenario we are handling here. Assume this to be your x. So from x raised to the power of 4, from this raised to the power of 4, it changes to what? X raised to the power of 5, this raised to the power of 5 over 5. Now over 5, but we're not stopping there. We are differentiating what is in the bracket. When we differentiate what is in the bracket, it gives us 3. So multiply by 3, we have this. Now I know if you are going to solve this on normal notes, it's going to take a whole lot of your time. That's using integration by substitution. It's going to take a whole lot of your time. But with this, we can solve this in seconds. Let's move further to more questions. So just we'll be solving a question like this, but in relating to trigonometry. Please, if you're enjoying this video, if you're learning a lot, put in the comment section that I love this video. Yes, it has a way of encouraging us. So now we have this question. The integral of 3 sine in bracket 2x plus 1 dx integrate with respect to dx. Now, if I'm to solve this question, it will be this. I'll be having plus c. Now, how did I get this? First of all, remember we have something like this, just like integration, using integration by substitution. You take this as your x. When you integrate this sine x, what do you have? You have minus cos x, right? And remember your x is this, so you put it as what? 2x plus 1, right? But then you're not done. Like we did here, we multiply by what? Over 2, which is the derivative of whatever is in the bracket. You get? And it brings us back to, okay, so we have 3 here, so let's not forget that everything multiplied by 3, since we have 3 sine this. So we'll be giving us 3 over 2 minus 3 over 2 cos 2x plus 1. Don't forget plus c. See, they can use this to trick you. They will give you a question like this. A will be the correct answer, the correct thing you got, but they will not put plus c. Then D will not be the same thing with plus c. You will not be fast and then click A. That's the wrong answer. So be careful. This is an indefinite integral, so you must have c as constant. If you are here to subscribe and you are watching this video, you are wrong. Yeah, so make sure you subscribe. Make sure you subscribe. Okay, we are moving over to another one. We have integral of exponential 1 over 2x dx. Now, we're told to integrate this, right? I think we did something like this earlier. Put everything the same way they are. But then, over what? Differentiate this. You'll be having what? 1 over 2. But I told us, when we have something like this, we can rewrite it as what? 2 over 1. So it will now be what? 2 exponential 1 over 2x plus c. So that becomes our answer. Is that clear? So these are various tricks on integration. But I'm not yet there yet to the whole lot of them, a whole lot of them, a whole lot of them. Let's take them gradually, small, 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 small. So we have another one. Okay, now we've been told to integrate cot x. We've been told to integrate cot x with respect to x. Now, and our answer is given in terms of, you have ln cot this, ln cos, ln sin x, ln sec x. So now, what I need you to know is cot is what? The inverse of tan, right? You see, COT, let me give you an OT. You see T here is ending with T. It means what? 1 over tan. And what is tan? Sin theta over cos theta. I'm just telling you all these things so that you know. So if it's inverse of tan, right? It will now be what? Cos theta over sin theta. Right? The x. But let's forget about this long talk. How do we get the answer? Remember I told you that okay, remember I told you that when you're having we solved the question like that where we had ln, you look at when you have something over something in integration, you look at the denominator. If you differentiate the denominator, if you get something that looks like the numerator, what do you have? Okay, first of all, let's check. Differentiate sin theta, you have what? Cos theta. That's what I have in the denominator. So if it fulfills that rule, what do? Ln what? What is down? Sin theta, yes, plus c. That is my answer. So please, It's simple and short. You don't need to start solving a whole long note. Okay, let's move to another one. We're just moving anyhow. If you're understanding, please say I'm understanding in the comment section. Okay. So I have this. I want you people to solve, and also my students on ground. Let's see who get the answer first. You have this to integrate. So let's see who gets the answer first. Between my students, between my students and you people online. So yeah, we have 15 seconds for this. Yes, you can try. Okay, that's exponential. Ax plus b
over A.
over
A.
a.
Yeah.
Okay, so okay, that's really nice. But do you know that without having a C, the answer is wrong. So please, very important. Very important, you must put a C. So very correct. When you have to integrate exponential, you put exponential ax plus b, put it there as it is. But don't forget, it's not just that. You differentiate whatever you have here. Remember, you differentiate with respect to x. This cancels out as a constant, and you have what? A. So it becomes exponential ax plus b over a plus c. Okay, I think we'll be doing more of question and answer. So yes, let's move to the next one. Okay, now we have a definite integral. Yeah, 203 for x cubed plus 2x. Now, this is a very cheap question. Now, for definite integrals, it's not really a shortcut, but I just feel let's do this. For definite integrals, the reason why you don't have plus is because you have lower and upper limits. So it is definite. The outcome is a constant. Yes. So now, what you just need to do is forget about this 2 and 3 for now. Integrate this. When you integrate 4x cubed, you'll be having what? X raised to power 4. You'll be having x raised to power 4, right? Then you have plus, integrate this one separately, you have what? X raised to power 2. Can you give a shout out to my students? They're really hot. Oh my. Okay, so now, after doing this, we have what? Our upper limit, which is 3, and our lower limit, which is 2. So in place for x, we put the upper limit and then the lower limit. So let's have this. We'll be having x. Okay, now in place of x, we put what? 3, right? Plus 3 raised power of 2. So we are done substituting for what? Upper limit. So let's put this in a bracket. Minus, it is always minus. After fixing in the upper limit, the next sign is what? Minus. You open bracket again, fill in the lower limit. 2 raised power what? 4 plus 2 raised power what? 2. So who can give me the answer from here? 3 raised power 4 is what? Okay? 3 raised power 2 is what? Minus 2 raised power 4 is what? 2 raised power 2. Okay, so it's 9, it's 1 plus 9. 90 minus gives us what? Now, you don't put plus C here. So these are definite integrals. They always arrive at a constant. It's definite because you've been given a range of values. While these ones that do not have down and up, they are indefinite, so they must have plus C. So let's move on. It's getting interesting, right? Okay. So now this is a very interesting question. And mind you, don't mix integration shortcuts for differentiation shortcuts. Very important. Please, please don't mix it. So we have integral of square root of 4x plus 3 dx. So now we can write it as what? 4x plus 3 raised power what? 1 over 2. Anytime you see square root, you can replace that 1 over 2. So it is still a function of function, right? Like function of function integral. So what you just do is what? 4x plus 3. Add 1 to the power, you have what? You have 3 over 2, and then you have 2 over 3 plus c. So this is what we did. Let me break it down. Rewrite this as this, right? You have what? Add 1 to this. Add 1 to this, you have 3 over 2. You still have this as your x, but then you interchange the fraction. So from 3 over 2 becomes what? 2 over 3. And that becomes our final answer. Yep. So the same thing goes for root of functions. Remember we did root of functions in differentiation. That row was separate from this. So anytime I have root of a function, it goes like this. Root of any function, it goes like this. That function will be here. 2 over 3 is constant, 3 over 2 is constant here. So let's move to the next one. So now we are asked to integrate um tan x respect to what? X. And now I've been giving our answers in terms of cos x and cot x, in terms of cos x and cot x. But never mind, tan x is what? Sin x over cos x. Please, you know all these things. I'm going the extra mile. This is supposed to be a short class, a shortcut class, but then let's do this. So now I said if you are able to differentiate this and get something that looks like this, good to go. So when you differentiate cos x, you have what? Minus sine what? X. So it means you'll be having what? Minus ln cos x. So after differentiating, you still have sine x, sine x. But what is left out? Minus. So you bring it out. Don't forget plus c. Very important. So can we move further? The one that is interesting me is partial. It's a question by parts. I can't wait to get there. But before we get there, we still need to do a lot of things. Yep. So okay. So yes, I think we have another question. We have integral of what? Root 3 minus 4x dx. Now, if you are able to look back, you just solved the question involving root, right? And this is what happened. You said 2 over 3, whatever function you have, 3 minus 4x raised by what? 3 over 2. But then, there is something important you need to note. Even after doing all this, you are multiplying the denominator by what? The differential coefficient of what you have inside. I guess was that made known in the last time? In the last time, was it made known? Okay, it was not. So please let us take note of that. When we differentiate what is here, when we differentiate, it gives us what? Minus 4, right? So minus what? So okay, let's do it gradually. So we have times minus 1 over 4. It's coming down. It's coming down. So we have what? minus 2 in bracket 3 minus 4x raised power of 3 over 2 over what? 3 times 4 is what? 12. So 2 here 1, we have 1 here, 2 in 12, 6. So now let's redo that particular question. Let's do it again. So please take notes while redoing the last two questions we solved. That's, I guess it was square root of 4x plus 3 bar, the x. So what we'll just do is, since it's square root, we put what? 2 over 3 bracket 4x plus 3, 3 over 2. But don't forget you're multiplying by what? Differentiate this, you have what? 4. It is, the 4 is at the denominator, so you have what? 2 here 1, 2 here 2. We're having 4x plus 3 raised power of 3 over 2 over what? 6. Don't forget. So are we getting it? Yeah. So let's move on. I can't wait. I can't wait for integration by part. Okay, so we have this question: integral of cos x over 1 plus sine x dx. Now, there's no need to waste your time solving for what is not necessary. What you just do, I told you, if you're able to differentiate the denominator and you get something that looks like the numerator, let's differentiate. We have this one goes now 0 cos x. So our answer is what? Ln 1 plus. Please, if you are feeling me, it's that simple. If you are feeling me, just give this a thumbs up. Yes, everybody watching, give this a thumbs up, and then subscribe if you're yet to do so. Yep. So let's go on. Let's go on. How many of you want me to move to integration by parts, sharp? If you want me to do that, my student want me to do that. Just go on the comment section and say integration by parts. Integration by parts. Yep. If I have up to 20 of that, I'll move to that as soon as possible. Yeah. Yeah, fire emoji. Okay, so let's have this question. Before I get 20 on ground, let's have this. You have 0 and 1. This is a definite integral because it's having what? Below upper and lower limits. So we have 2 over what? 1 plus 2x dx. Now, first of all, when you have something like this, a definite integral, you have to integrate and then fill it up. So this is what happens. If you have something over something, try. If you differentiate and it gives you something related to this, the answer is what? Ln, right? Yes. So we'll be having when we differentiate, we'll have what? 2, which is the same thing as this. So we'll be having ln what? 1 plus 2x, right? Yes. Upper limit 1 and 0. So what we're having is ln 1 plus 2 times 1 is what? 2, right? Yeah. This 1 minus ln 1 plus 2 times 0, 0, right? So ln 3 minus ln 1. It should give us what? So this is what my students say, ln 2. So we'll be moving over to another question. But then, before then, we'll go for a short break and then we'll be right back. The answer. So welcome back from this quick break. If you're here to subscribe and you've been on this live session since, please do not subscribe. Yep. So we have these two questions, and in order for us to solve this, yes, the x and the x. So we can just open the bracket. We have x squared plus x, right? Integral of 0 to 2. So we integrate this. Integrating this, we have what? X cube over 3, right? The power here is 1, add 1, becomes x squared. This same thing, bring it down. So upper limit is 2, lower limit is what? 0. So let's fix in upper limit into this whole thing. We'll be having 2 cube over what? 3 plus 2 square over what? 2. So this upper limit, minus is always minus. Let's fix in lower limit. We'll be having what? Now, don't need to solve. 0 cube is 0. Everything becomes what? 0. So we're having what? 2 cube is what? 8. Okay, let me now go into another. We have 8 over 3 plus what? 4 over 2. So we are 8 over 3 plus what? 2, right? So put it together as one fraction. We're having what? LCM 3, right? 3 times 2, 6. 8 plus 6 is what? 14 over 3. So this is what we're having. Or 14 over 3 is what? 4 whole number. 2 over 3. So this becomes our final answer. So let's move to this particular one. I told you when you have something over something and you're integrating, check out for. If I differentiate this, will it give me something that looks like this? So let's differentiate. We're having what? 2x plus what? 2. It looks like it because if you factor out 2, we're having what? X plus 1. So our answer will be what? Ln what? X squared plus 2x plus 5. But then we'll be having 1 over 2. You know, 1 is here and then we have 2 here. 1 over 2. So do you understand, right? It's as simple as that. Plus C. Let's not forget. Yeah. So is there another question to solve? Okay. Okay, so let's move to something spectacular. What we've been waiting for all this while. Please, my student, can you tell me what it is? Yes, integration by parts. So let's do that. Okay. Okay. Okay, please, let's go on a short break. You need to go on a break so that your head will not explode. I'm just joking. Okay, so we've come to it. Integration by parts. And then we have integral of this and integral of this. Hey, my voice has to be deep here because this is deep. Okay, so truly, if we are going to solve this through integration by parts, it will take us a while. It's going to take us a while because after doing integration by parts, we'll still have another integration by parts, which will still have to integrate again. So it's going to take a bulk of your time, and that's why we come out with this shortcut. So now, look up. When you have something like this, right? You have 1 over. Now, what I'm meant to do is, sorry. Okay, let me move back to the question to be sure that that's actually it. Mm, okay, sorry. Yes, we'll be going for a short break. There's a mix up somewhere. Yeah, see you soon.
It's a principle. When you pay the price, you automatically walk into victory. This is Daniel. He has paid the price for MAT121, and that's why he's confident about his victory. It's a principle. When you pay the price, you automatically walk into victory. This is Daniel. He has paid the price for MAT121, and that's why he's confident about his victory.
Okay, welcome back. Sorry for the hitch. What happened was, the shortcut for this was we're not able to get a shortcut for this. So it's just the normal method we're going to go through, using the normal integration by part rule. So, but if we're able to get this particular shortcut, we'll do a video and release it out. But then the two major ones that I've seen to really help matter is the one involving x and the one involving exponential and a trig. So the shortcut about the one involving x is this. You differentiate this and you integrate this, right? The one involving x, you differentiate the one that, yes, and you integrate this. So when we differentiate 5x, we get what? 5. When we differentiate 5, we have what? 0, right? Now, for this, if we choose to integrate exponential 4x, remember I told us we will still have exponential 4x, but then over what? 4. That's one. If we decide to integrate again, what do we have? We'll still have exponential 4x, but now over what? 4, which is what? 16. So now, since we've reached where we have 0, we stop. We put our sign plus, minus, goes on like that, if it still proceeds. So now we do this, we merge this together, and then, so the arrow keeps going down, it keeps going down. But since we just have one arrow, our answer will be what? 5 exponential 4x over 16 plus c. So now, looking at this, we have exponential and we have a trig. Now, the trick to this is you put 1 over square this. Please pay keen attention. If you are going to solve this, it's going to take you a long period of time. So this is how you go. As far as you see exponential and then you see a trig, either sine or cos, square this, square it. When you square it, you have what? 9 plus square this. When you square it, you have 25. 9 plus 25 gives us what? 34. So we're having 1 over 34 here in bracket. In bracket. So what do we put in this bracket? Keep this constant. Keep exponential. Keep it constant. Differentiate this. We have what? Minus 5, right? So let's write it together. We're having minus 5 exponential 3x sine 5x. And then we have plus, right? We keep this constant cos 5x constant. We differentiate this. So we have what? Yes, we differentiate. 3 exponential 3x. So we differentiate, 3 comes here, exponential 3x remains. So now that we are done with this, we can factor some things out. We'll find out that we have exponential 3x here and exponential 3x here. So we can say exponential 3x over 34 in bracket. Now, our final answer will be that for the first one, we multiply it by minus, the second one, we leave it like that, or we multiply by plus. So if I'm multiplying the first one by minus, it becomes what? 5 exponential 3x sine 5x. Multiplying this one by plus, it still remains plus. So 3, no longer exponential. Yeah. 5 sine 5x and 3 cos 5x plus c. This becomes our answer. Now, I said if you are able, if you want to solve it, it's going to take a whole while. So let me come again. The integral of exponential, when you see exponential and a trig, either cos or sine, this is what you take note of. You see, we did one involving x. When you see anyone involving x, this is what you follow. But when you see exponential and trig, this is what you follow. You say 1 over square this thing, add it to the square of this, right? It gives you what? 34, 1 over 34. So open the bracket, keep this constant. Keep exponential 3x constant. It's constant here. Nothing is touching it. Differentiate cos 5x. When you differentiate cos 5x, you have what? Minus 5 sine 5x. I'm just trying to do it together. So minus 5 sine 5x. The next one, keep this constant. So you keep this constant. It's not touched. Differentiate exponential 3x. When you differentiate, you have what? This 3 exponential 3x. But then your final answer will be that you will multiply the first term by what? A negative. So minus times minus gives us positive. And then the second term, you leave it as it is. So yes, you leave it minus. But it's just the first term that is affected. It means for every time you are going to take exponential 3x as you keep it constant first. Yes, you keep it constant first. So let's solve another question so that you get familiar with this. Let me see. Do I have another question like this? If you are really enjoying it, see, give us a thumbs up and say I'm enjoying it on comment section. So we have exponential. Yeah, that's what we solved. I'm looking for another question. Um, can we get another question in this format so that I'll be able to explain it well for you? Okay, sorry, I'm looking for one. Okay, let's solve something like this again. Okay, we have exponential minus 2x sine 3x dx. Now, this is involving exponential, right? And it's also involving a trig. So what we do is 1 over, right? Minus 2 squares is what? 4. Plus 3 squares is what? 9. 9 plus 4 is what? 13. So we'll be having 13 here. In brackets, keep, you are keeping your exponential constant. Keep exponential minus 2x constant. Differentiate this, you have what? Cos 3 cos 3x. So you put your 3 here. Then plus what? Keep this constant, you'll be having sine 3x. Differentiate this, you'll be having what? Minus 2 exponential minus 2x. So what happened was you kept this constant, you differentiated this, you have 3 cos 3x. Next one, you kept this constant, sin 3x, nothing happened to it. You differentiate this. When you differentiate, it becomes what? Minus 2 exponential minus 2x. So that's what we have here. But I told you, you do what? To the first one, let's factor out exponential minus 2x, exponential minus 2x. So we have exponential minus 2x over 13 in bracket. What do you do? Minus the first one, minus 3 cos 3x, because exponential has already, we have factored it out. Then leave this as it is, 2 sine 3x plus c. So this becomes our answer. So like I said, you want to follow due process, please try it, try it. It's except you have tried it that you appreciate this. So now let's solve one more question on this. So we have integral of x cos x dx. Now remember what I told you, what I told you, what to do in case you have x. So what we do is Differentiate x, you have what? 1. Integrate cos x, you have what?
Integrate cos x
Yes.
as sin x over that's
Sin x, right? So differentiate 1, you have what? 0. Integrate sin x, you have what?
minus cos x.
Minus cos x. So it means this plus this minus, right?
Yes.
1 times minus cos x minus cos x plus what? C. So it keeps on going like that, diagonally.
So I have a question.
Yep.
So you just keep on differentiating
Yes,
the x
yes,
until
and
you get
then
to zero.
yes, and then you keep on. Okay, sorry, sorry. Thank you for that. Let's write it out first. Okay, we have x, right, and cos x. So we start from this, we move towards this. So yeah, we had 5. Okay, we have 5x, Abi. Okay, thank you for this. Thank you for this. Please note, we are starting with 5x. So 5x comes to this place. I was supposed to write 5x out. 5x comes here. 5 comes here, right? 0 comes here. There's nothing here. So how about 5x times what? Exponential 4x over 4. So we're having something like this. 5 over 4 x exponential 4x. So this plus, this minus, this plus. So this plus, the next one is what? Minus. Minus this. So thank you very much for that. And then for this, it moves from here to here. It becomes what? X, this plus. Next one is what? Minus this plus. It moves from x to this. It becomes what? X sine x, right? Minus times minus gives us what? Plus. Plus cos x plus c. So that's how we go about it. Yep. So very important. You start from this place. You start from this place. Positive, the next one negative, positive. So it goes diagonally. Yeah.
Is it that you differentiate the x and you
Yes.
integrate the other part?
Yes. Yes. Because you're looking for the only where you can stop is when you have 0. So it's easier for you if you are differentiating x to have 0 than if you are integrating x.
Yes.
So you choose the one that is much more easier. You get. And this is how we get the answer. So please take notes. We started from here, differentiate this down to where you have 0, integrate this till where the partner is 0. You have plus for the first one, minus, plus, minus, like that, and you multiply diagonally. So 5x multiplies this, we have this, minus 5 multiplies this, we have this. X multiplies this, we have this. Minus 1 multiplies minus cos x, we have this. So now, these are the shortcuts we have for um, integration. We've done shortcuts on basic integrations. We've done shortcuts, integration by substitution, by factorization. When we have product, which is where we make use of integration by parts, and also where we have quotients, we have divisions. So I'm sure we've learned a whole lot from this. So I'd love us, if you're here to subscribe, I'd love you to subscribe to this channel and tell your friends about it. Very important. Share these videos to your departmental groups. Share it too on your status. So a lot of persons benefit from you. It's nice having you on this live show today. See you some other time. I wish you good luck in your exams. Bye.
It's a principle. When you pay the price, you automatically walk into victory. This is Daniel. He has paid the price on MAT121, and that's why he's confident about his victory. It's a principle. When you pay the price, you automatically walk into victory. This is Daniel. He has paid the price on MAT121, and that's why he's confident about his victory. It's a principle.